Alright, so I have here a crude setup to measure magnetic susceptibility. So right now this is basically a GUI balance, a really crude GUI balance. And what I have is basically a 3D printed cell with two magnets that are facing each other. So the north and south are facing each other. I have a scale that measures to the milligram, and I have this custom glass tube I made from a pipette, and I've filled it with copper sulfate, which I've ground up using a mortar and pestle. And what I'm going to do is I'm going to stop talking so the air currents settle down, and I'm going to hand insert this in between the two magnets, so where the bottom of the sample is in the center of the magnetic field, and the top is on the outside. So that's important that they're actually in a gradient magnetic field. And with the setup, I could theoretically calculate the number of unpaired electrons within this copper sulfate sample. I'm just going to stop talking. I'm going to let the air currents sort of settle down, and then I'll insert this tube a couple times in between the magnets, and we should be able to measure the change in mass. Okay, so my scale isn't entirely accurate. As you can see, it's now measuring 18 milligrams. What happens is that, what happens is that when it has some uncertainty within the milligram area, it sort of just zeroes itself out. So I'm measuring that. So I'm going to zero it quickly. Scale isn't exactly balanced. So any sort of vibrations in this magnetic cell sort of can be detected. So normally when you do these kind of measurements, you do take into account the magnetic properties of your tube. So I have an empty tube here, but I'm just going to demonstrate that my scale isn't precise enough. So the effect that these tubes may produce is pretty negligible. Okay, so you can see that there was no weight change, but if I get the tube of copper sulfate back, and I insert it in quickly, you can see there's a weight change. Now, to prove that it is actually the copper sulfate interacting with the magnets to cause this change in mass, I'm going to quickly take out the magnets, and I'll repeat the same experiment by inserting the tube of copper sulfate into the cell, and we should expect to see no change in the mass. Okay, I've brought the tube back. This time there are no magnets. I'm going to insert this tube of copper sulfate, and as you can see, there is no change in mass. So from here, I could theoretically be able to calculate the number of unpaired electrons within the copper sulfate sample. Now, it would be nice if I had some actual, complexes with me, with some large ligands. However, I do not have that here in my house. So copper sulfate will do, especially since that's the easiest, thing I can get at the hardware store. So anyways, hope you enjoyed.